All right, welcome back. In this video, we're going to do just a couple more examples of prime factorization. So we had seen in the last video that prime factorization, the answer is unique, but depending on how you choose to show your work, you may get different looking scratch work, and that's okay. So let's just try these. The first one is going to be 240. I'm going to do this first using the tree diagram way. And again, regardless of how you choose this first factorization or any of it, your end result is going to be the same. So here to me, 240 is going to be 10 times 24. And 10 is 2 times 5. And I'm going to keep going down, down, down until I can't break down the numbers any further. 24 is 6 times 4. 2 and 5 are done, so I'm not doing anything more to those. 6 is 2 times 3. And 4 is 2 times 2. Now, you may wish to highlight or circle the numbers at the ends just to make sure that you don't miss any, or write one down twice, which would be also unfortunate. But we have 1, 2, 3, 4 factors of 2. So that's 2 to the 4th power. There's 1, 2, 3, 4 of those, and then a 3 and a 5 times 3 times 5. And if you like, you can double check by multiplying that back out and ensuring that you actually do end up with 240. Okay, so let me try this one also using the repeated division method, just so you can see another example of that. So to me, the downside of this method is that it's there's less choice, I guess. That could be an upside for you because it's more methodical, but I like 240. I could split that up in a lot of ways. I could use whichever way occurs to me first. I use 10 times 24, but this one is more methodical. So we're going to go 2 into 240 goes 120 times. 120 divided by 2 is 60 times. Divided by 2 again is going to give 30. And finally, we've run out of 2s. I should have one more 2. I have one more 2. So 2 goes into 30 15 times, and we're out of 2s finally. And so 15 is divisible by 3, that leaves 5. And so again, we have the same answers we had before. There were 4 factors of 2, and then a 3 and a 5. Okay, let's try 2 more of these. We have 56 and then 300. So let's try 56 next. 56 is 7 times 8. Okay, 7 is prime, so we're done with it. 8 is 2 times 4, and 4 is 2 times 2. So there's 1, 2, 3 factors of 2 and a 7. So 2 cubed times 7. And that's the end of 56. Lastly, let's do 300. Okay, so 300 is 10 times 30. So we'll continue with that. 10 is 2 times 5, and 30 is 6 times 5. The 2 and the 5s are already primes, so there's nothing to do there. Instead, we'll focus on our 6, which is 2 times 3. Okay, so we'll have 1, 2 factors of 2, and then a 3, and then 2 5s. It's again a good idea to mark off the ones that you've counted so that you don't accidentally forget one or use one twice. And also notice that you're just using the numbers at the ends of the tree diagram. I didn't write down a 10 or something. You want to write down only numbers ending up at the very bottom. And they should, of course, be prime numbers if you're doing a prime factorization. All right, so then one more thing to do, and that is to talk about divisibility tests. In some of our examples, it was not maybe quite clear how I knew that a number was divisible by another number. For example, I knew that 105 earlier was 20 times 5. Well, how did I know that so quickly? Aside from the fact that I wrote the example, of course, right? And so there's tests or checks that you can do to determine whether one number is divisible by another. For example, 51, people always think 51 is prime just because it kind of looks prime, but it's actually 3 times 17. Okay, and 51 is divisible by 3. So how do you know that kind of stuff? That's divisibility tests, which we're looking at next. So what a divisibility test is just a test to see if one number is divisible by another. We're going to go through a few of these. So 2 is probably the easiest one. You've been a student long enough doing even and odd problems that you know whether a number is divisible by 2 or not. If the number ends in 0, 2, 4, 6, or 8, it's an even number. It's divisible by 2. If you divide it by 2, it's going to come out even. There won't be any remainder. Okay, so a couple of examples. 24, 518, 24 ends in a 4, 518 ends in an 8. Those are even numbers. They're divisible by 2. 63 and 805, those are both not divisible by 2. They don't end in 0, 2, 4, 6, or 8. That one is probably the easiest, most familiar test. Let's check the test for 3 next. I think the test for 3 is kind of fun. You add up the digits of the number. If you get a number that's divisible by 3, then your number is divisible by 3. So here, 27, what's 2 plus 7? 2 plus 7 is 9. Is 9 divisible by 3? Yes, 9 is 3 times 3. And since that's divisible by 3, 27 is divisible by 3. So that's yes. 5,181, 5 plus 1 plus 8 plus 1. Okay, that's 15. Is 15 divisible by 3? Yes, 15 is divisible by 3, so this number is divisible by 3. 2,131, it's nice and odd looking, but is it divisible by 3? 2 plus 1 plus 3 plus 1 is 5, that's 7, right? 7's not divisible by 3, so this number is not divisible by 3. I'll leave it to you to check the 169 is not divisible by 3. Okay. For 4, to check and see if a number is divisible by 4, you look and see if the last 2 digits form a number that's divisible by 4. So for example, 5,124, I know that 24 is divisible by 4. And since 24 is divisible by 4, 6 times 4, right? Since 24 is divisible by 4, our original number is divisible by 4. 348 is divisible by 4 because 48 is divisible by 4. Okay, for 722, 22 is not a multiple of 4, so 722 isn't. 914, 14 is not a multiple of 4, and so 914 is not. Okay, by the way, you can combine these to check and see divisibility for higher numbers. Since you know, for example, 12 is 3 times 4, if a number is divisible by both 3 and 4 separately, then your original number should be divisible by 12, because dividing by 12 is the same as dividing by both 3 and 4. Okay, divisibility test for 5. If a number is last digit is either 0 or 5, then your number is divisible by 5. So for example, 35 divisible by 5. 400 divisible by 5, because all you do is look at the last digit. Does it end in a 5 or 0? 53 and 87, neither is divisible by 5 because neither ends in 0 or 5. Okay, the test for 9 works like the test for 3 does, because 9 is 3 times 3. That shouldn't be too shocking. You add up the digits and see if you get a number that's divisible by 9. So just to try a couple of these, 1 plus 7 plus 1 is 9, and 9 is obviously divisible by 9, so 171 is divisible by 9. That's kind of neat because it doesn't look necessarily like it's going to come out, but you can try it by hand if you want, that it does. Okay, 6 plus 8 plus 4. Okay, that is 18, right? And 18 is 9 times 2, so yes, that will definitely work. Okay, 39, not divisible by 9 because 3 plus 9 is 12, which is not divisible by 9. It is, however, divisible by 3. Okay, 78, 7 plus 8 is 15. That one also divisible by 3, but not divisible by 9. Okay, so the usefulness of these tests, what are they for? Why bother? In part just because they're kind of neat, and in part because you can use them to help you simplify fractions sometimes. So for example, we're not doing fraction simplifying now, but let's just say we were. If you wanted to know if the fraction 104/58, I just made that up, if that simplifies or not, one of the things we would need to know is what are the common factors between 144 and 58. And now, based on what we just talked about, we know that both 144 and 58 are divisible by 2. And that's going to help us in some way. The 144 we saw is divisible by both 9 and 3, but unfortunately 58 is not divisible by either one of those. So knowing whether the numerator and denominator of a fraction are divisible by something, the same thing preferably, that can help us simplify the fraction, as we'll see. Realistically, you're likely to run across fractions like this in a math class more often than you are anywhere outside of a math class. Outside of math class, at work or cooking or building something or sewing something, the kinds of fractions that you're likely to run into have denominators of 2, 3, 4, numbers up to 26s, 8s, 16s, 20s, 20 to an extent, and then powers of 2, so 32s, 64s, maybe higher than that. But most fractions that you're likely to run into on a day-to-day basis don't have these kind of crazy denominators. Okay, so knowing the divisibility for some of these lower numbers is more useful than things like 144/58. But just in case, having the divisibility tests can help you. Probably the most use you'll get realistically would be the tests for 2 and 3 and 5 would be the most commonly used tests. All right, that takes us to the end of everything that we need about prime factorization, especially as it pertains to fractions. So let me know if you have any questions, and have a great day.